All right, guys, today we're going to learn about binomial probability. But first, before we learn how to the probability part, we're going to have to determine if a situation is binomial, because it has to be binomial in order to do binomial probability, okay? So there are 4 characteristics that make something binomial, and it actually spells bin, B-I-N-N. So the first thing to be binomial is going to be there only has to be 2 outcomes. Okay, it can't be more than one. Now, it can be simply as it's green or it's not green, okay, but it can't, your options can't be red, green, or yellow. It can only be 2 options, okay? Independence. Each trial has to be independent. That means every time you do this probability, it doesn't depend on what you just did. So, for example, flipping a coin. When I flip a coin and I get a heads, does my next flip depend on what I got previously? No, you're just flipping a coin. You're just going to get what you get, okay? Now, when you're drawing cards, so say I draw a card. I draw 1 card, and I get an ace of hearts. And then I keep that card, and then I draw again. When I draw again, can I get that ace again? No, I've already drawn it, so I can't. So that would be an example of dependent. Now, the number of trials is fixed. You have to know how many trials. It's not just until you get something. No, you need to say, I'm going to flip the coin 3 times and see how many times I get heads. It's not, I'm going to flip the coin until I get heads. Okay, you can't do that. And then the last N has to have the same probability for success or failure for all the trials. Well, that kind of goes with the independence one. Okay, they're kind of the same almost. Your probability has to be the same. So like every time I flip a coin, I have a 50% chance of getting heads every time, okay? That's what I mean by that. All right, so we're going to do some examples. This is a really short video, okay? So we want to know if it is binomial, and it has to pass all 4 of these. If you say no for one, it's not binomial, okay? All right, so tossing a coin 20 times to see how many tails occur. All right, B, is there 2 outcomes? Yeah, I'm either going to get a heads or I'm going to get a tail. So we're good with B. I, is it independent? We've already stated tossing a coin is independent, so it's independent. Do you know how many times you're going to flip this coin? Yeah, I'm going to flip it 20 times, so we're good. And the last N, does the probability stay the same? It does. So you will say, yes, this is binomial. Okay, next one, rolling a die until a 6 appears. All right, so what are my outcomes here? Well, I want a 6, right? So I'm either going to get a 6 or I'm not going to get a 6. So there's 2 outcomes, okay? Now, independent, each trial is independent. Yeah, when you roll a die, it doesn't matter what you roll first. What you roll first doesn't determine what you're going to roll second. So it's independent. The next one, number of trials is fixed. Do I know how many times I'm going to roll this die? I know I'm going to roll it until a 6 appears. Well, what if I roll it and a 6 appears on the first roll, but then say Madison rolls it and she doesn't get a 6 until 5 rolls? So it's not fixed. So this is not binomial because, and you can just say because of N, the number of trials is not fixed. Okay, that's why this is not binomial, okay? All right, C, rolling a die to see if a 5 appears. Well, are there 2 outcomes? Yeah, I'm either want a 5 or I don't want a 5, right? So there's your 2 outcomes. Is it independent? Well, we've already stated rolling a die is independent. Now, this is where the last one messed up on. Is the number of trials fixed? How many times am I rolling this die? It says I'm rolling a die just to see if I get a 5. So I'm only rolling the die once. So yeah, it is fixed, okay? You see this word right here, until, that's what makes it not fixed. It's not there, so we're good, okay? And then the last one is the probability the same for success or failure? It is. You either got a 1/6 chance of getting a 5, you got a 5/6 chance of not getting a 5, and that stays the same. So this is, yes, this is binomial, okay? All right, D, asking people if they watch ABC News. Well, if I ask you if you watch ABC News, that's only a yes or no question, right? So that's 2 outcomes. Is it independent? Yeah. If I say I watch ABC News, then George can say he doesn't watch ABC News, but it had nothing to do with me. So it is independent. The number of trials is fixed. How many people am I going to ask? I don't know how many people I'm going to ask. So it's not fixed, okay? So this is not binomial for the same reason as that, okay? Asking people how old they are. Okay, so how many outcomes could it be? Well, I'm 35, but I asked one of you guys, you could be 18, you could be 17. Then I could ask somebody else and they could be 40. So there are multiple different outcomes here. So this is not binomial because multiple outcomes. Okay? Drawing 5 cards from a deck. All right? Are there only 2 outcomes? Well, it doesn't state what I want to draw, does it? You see how up here in B and C it stated I want to roll a 6 or I want to roll a 5? That's why we could say a 5 or not a 5. But here, it doesn't say what I want to draw. It just says I want to draw 5 cards. I don't have 2 outcomes here because I could draw an ace of hearts, an ace of spades, an ace of clubs, an ace of diamonds, and I could keep going on and on. So this is not binomial either because of the multiple outcomes. Okay? All right, so that is it for how do you know if to use binomial probability or not. All right, guys?